Now that we have the Jasper audit into our web server, let's take a look at the Scale Web GUI to see how we can use it to conduct a scale audit. So if I go into Jasper, we will be presented with a bunch of diagnostics. I'm going to go ahead and click on this one just to bring up some interesting stuff at the bottom. But for now, let's look at the top half of our GUI. We have 10 diagnostics available out of a total of 2783. And as you can see here, you can look at any different batch of 10 diagnostics. You can also choose to look at more diagnostics if you want, up to 500. Looking at 500 diagnostics can take a while, so 10 is the default. So the diagnostics consist of effectively one large table of almost 3,000 diagnostics in this case, with a whole bunch of columns. So what does each column here mean? A few of them are obvious. The path and line columns, for instance, represent the path name of the file with a problem in it, and the line number. And as you can see, you can click on each line to actually bring up the source code, in this case line 563 of this file, jazz_cm.c. The message is a textual message that was produced by the tool, PCLint in this case, and the message just simply is the tool's description of what the problem actually is. So you'll notice in these first three diagnostics, the tools and messages are very similar, but with some slight differences. Conversion of floating point to smaller type, integer type, floating point expression. But there is a lot of overlap here. The tools available are, of course, all the tools that we ran, PCLint, Fortify, and so on. We also have a field here called checker. What is a checker? A checker is effectively a sort of error indicator that each tool uses to classify and categorize the diagnostics that it produces. The interface provides us with a list of all the checkers that were produced by all the tools that we ran. And as you can see, many of them are produced systematically by the various tools. For instance, PCLint uses numeric checkers, numbers from about 1 to 2,000, to represent the different categories of errors it can find. Other tools use different mechanisms. These ones that begin with the letter C and a 4-digit number were produced by Microsoft Visual Studio. The ones that look like CERT, Secure Coding Rule IDs, like these two, were produced by Rose Checkers. And finally, a few tools, such as GCC, do not provide any error ID, so instead we perform regular expression parses of the error message and associate with a regular expression. So GCC would say implicit declaration of variable foo, and it matches this regular expression, which catches all errors associated with implicit declarations. So each checker that we identify is associated with a single CERT rule. A few checkers are associated with no CERT rule. They don't indicate security problems. But each CERT rule then provides information about what is being violated. These diagnostics all allegedly violate rule FLP34-C. I'll bring up that rule here so that you can peruse it. So FLP34-C is about floating point rules, and it basically warns about losing precision or important information when doing a floating point conversion. Every CERT rule consists of some normative text saying what you shouldn't be doing, some backup information, usually from the C standard, a couple of code examples, the non-compliant ones saying what you should not do, the compliant ones saying how you could fix them, and each rule concludes with a risk assessment with some critical metrics about how likely it is for a violation to be exploited, the severity of the exploit, how expensive it is to fix it, and the priority. The priority metric is an amalgamation of all of these items. In this case, the priority is 3, which indicates that this rule is a fairly low priority one to pay attention to. So I'm going to go back to the scale GUI, and you'll see the risk assessment values are duplicated here. The priority again is 3, and can range from 27 to 1, where 27 represents the items that we should audit first and the client should fix first. Moving on, the items to the left here, first of all, you have a ID, which simply represents a unique ID for each diagnostic, and you can bring up a specific diagnostic by bringing up its ID here. The flag is a simple on-off value which is stored in the database, and it doesn't really have any predefined meaning. You can use the flag for anything you wish. The verdict is the important thing. All diagnostics initially start off with a verdict of unknown, but you can change it to one of these other values. The previous field is the previous verdict. If we were to do an audit on this code base, and suppose we get a new version of the code base to audit, perhaps they fixed the previous problems, then the verdicts that we provided in the first audit would appear under the second audit under the previous item. So if I mark this as true here, then during the second audit, we would see a true slot in the previous field. Since this is the first audit of this code base, the previous field is unknown. The values for the verdict, again, they all start off as unknown, meaning we don't know a thing about each diagnostic. And the goal of each audit is to fill the verdict for every diagnostic to some value other than unknown. You can set it to true, indicating a diagnostic represents a true violation of the CERT coding rules. You can set it to false, meaning the diagnostic is a false positive and does not represent a violation. The code is perfectly good. The suspicious value is useful for indicating diagnostics that we simply don't have time to audit. With 3,000 diagnostics to worry about, we can only audit a handful of them. So what we will do is we will mark a few of them as true, mark the bulk of them as suspicious, and mark a few as false. We will only mark a diagnostic as suspicious if there is already a true diagnostic under the same rule. If we know the code violates rule FLP34-C, for instance, we could mark all of these diagnostics as suspicious and save ourselves some time. And finally, the ignored value is for diagnostics that we do not wish to audit or cast any judgment on for various reasons. Perhaps we don't have the source code available. Maybe the source code is auto-generated by another tool. And that represents the columns here in our Scale GUI.